Alright, hello everyone, and welcome the frick back, you guys. Today we're going to be doing our seventh and final independent instruction lecture, and that is going to be doing basically expanding off of what we did last time, and sort of concluding our unit for basic CAD knowledge, right? So at the end of this lesson, right, I mean, you already probably have most of the knowledge you'll need in order to, or at least most of the facts you'll need in order to build, or in order to use CAD to interpret your designs, to enact your designs, because it's mostly simple stuff, right? My bad there. You probably already have most of the knowledge you'll need, and the rest will come with practice. You at least have most of the facts you need. All of the knowledge and the ability that you'll need will come with practice of doing what we've been covering. And that's literally all you'll need is just practice. But yeah, so we're going to be doing a little bit more relatable assemblies to robotics, and we did that a little bit last time with the right angle joint assembly. But today we're going to be doing something a little bit more advanced. Not even advanced, just a little bit more applicable, because it's really not that much more complicated, but it is more applicable. So now we'll move on to this project, right? Our practical assembly is a robotics drive base, right? And that looks very complicated, right? You've got wheels and gearboxes and motors and metal. Yeah, it's super complicated. I don't think it's that complicated, but it's. Oh, I went to the YouTube video by accident. I don't think it's that complicated, but it is. It is, bigger. It's physically larger. It has physically more components, so it can seem a little bit daunting at first. But we're going to take this and we're going to turn it into this. All right, we're going to take this and we're going to turn it into this, and it shouldn't take us long. Right, we already know how to do assemblies in CAD using mates, so we'll just work through that, and I'll show you guys a few tips and tricks to be doing that, and then we'll show relatively like, how simple this actually is. Right, you have one of these on your robot, and then the rest of your mechanisms are not any more complicated than this really, and they're all mounted on this, and you only have like two or three or maybe even four others other than your drive base. So yeah, a robot's not that complicated is what I'm getting at here. But first things first, let's go ahead and go to our documents here, right? So we're just going to go ahead and go to our CAD here, to off-season 2020. And then we'll go to presented practice documents, and we'll go to drive-based practice assembly. We'll make a copy of it as usual. If you don't have access to the team, but you're on the team, then go ahead and send me your email for Onshape. I'll go ahead and add you. And if you're not, if you're just watching this on YouTube, then just go ahead and follow along with what I'm doing on screen. And if you would like, you can go ahead and download these parts off the internet like we did last time and modify them from scratch. Actually, I think that's a good challenge, and I'll try to, say what these different parts are as I go. But yeah, so we'll go ahead and copy this workspace, and we'll name it Lucian Genova. That's my name, by the way, if you guys haven't figured it out yet. And we're gonna, as soon as this opens, we're actually gonna go back and then move it to my folder. Right, we have to have proper file management here, just so we know where everything is. So we'll move this to, we can actually just drag it to off-season here, and we can drag it into team member folders, and drag it from team member folders into drive-based practice assembly, drag it from team member folders into my folder, which should be at the top up here. Will it not allow me to, crap, nope, we don't want, I have no idea where I put it. It's possibly just gone. It may just be gone. Okay, well, that's exciting. We'll just have to go ahead and make another copy of that. Yeah, so we'll go to independent practice. Nope, that's not the right thing again. Man, I must really be goofing up here because I am not doing anything right. But we'll go ahead and go to here, and we'll go and we'll make a copy of this. We'll name it after ourselves. And I'll put a period after that just so that we might know it's different. I don't know why we would do that. It seems like a useless gesture because we don't even know where the other one is. It's in some random team members folder. They're going to see it and they're going to wonder what the heck it is. But we'll go back to here and we'll go ahead and move it to here. And we can go ahead. No, yeah, okay, yeah. And we'll go ahead and move it to team member folders and my folder. All right, move it here. Okay. We'll go to independent practice, or no, we'll go to my folder, which will be down here towards the middle, and we'll go ahead and open this up. we moved the wrong thing. We moved the legit one instead of the copy. Well, that's acceptable. We'll just rename this one to be my name. All right, we'll rename that one. Okay, so you can see it's actually opening us up on the drawing, and we'll get into making that in a bit. First things first, though, let's look at what we've got. So what is this assembly like? Okay, this is the fully assembled reference, right? And what it's got is you've got your chassis, which is just this metal here, and you've got your drivetrain, which is going to be this motor, this gearbox, these wheels, and then the bearing blocks that they're on, as well as the sprockets that connect them. And I've tried my best to make everything sort of in this assembly video. We won't be constraining everything like we would be in real life. We'll be using grouping in order to get that all constrained. But you can see when you spin one of these wheels, the other ones spin as well, or at least these rear two do, because this one isn't actually powered. So for those of you who don't have access to this, this isn't actually VersaFrame, but you can use VersaFrame. This is going to be VersaFrame, right? 2x1 VersaFrame with 0.1 wall thickness, and the length is going to be 29 inches here. 29 inches, and then this one is going to be shorter. This one's shorter, 27. And because each one of these is 1 inch wide, 27 plus 1, 2 is 29. So it's a 29 by 29 drive base. Pretty standard stuff. And now these motors are going to be sim motors. So if you look that up on like Vex or West Coast Products or something, you'll be able to find and download that file. And then this gearbox here is a West Coast Products. It's not an SS, it's a, I'm not entirely sure. You can just use a WCP SS gearbox, and that'll give you effectively the same thing as we have here. And then this is you can just look up this is a 6-inch traction wheel from Vex Pro, and this is a 6-inch omnidirectional wheel from Vex Pro, and these are West Coast Products bearing blocks, sliding bearing blocks. And then this is just a bolt here. We won't be getting too much into detail. The thing is, when you're making all of this, it won't already be sort of in place, so you'll be having to pretty much make everything. But even then, that's not that much. It's just making all of these little sub-assemblies and copying them. Like this is the same as this, and then all these bearing blocks are the same, and then copying them over, right, so that they're usable on this full assembly. So what we want is this little configuration with our drive base here, and then we'll need to put our bearing blocks in place, and then we'll need to put our gearboxes in place, and then we'll need to put all 6 of our wheels in place. But that's pretty simple, right? It's not going to take us too long. There aren't any bolts in the CAD here, or at least not holding the frame together, just because I think bolts, you can use bolts in your CAD, but when you're trying to make CAD quickly, usually you only put bolts in your CAD when you're doing like the finishing touches, Although sometimes they can be really important to the design, like if you want to know how much clearance you'll need for a bolt, you can do that. But yeah, usually you don't need bolts in your CAD unless they're like, they have a reason that they need to be there, or unless they like you're using them just to sort of represent the whole thing. Like if you were to make this drawing here, right, just to show somebody how to assemble this, you would want to have bolts there, just so that they can see where the bolts go, how many bolts you need in each slot, or in each hole. Not in each hole, you can only fit 1 bolt in 1 hole, but how many bolts you would need at each joint, right, because you can fit 3 or 4, but you might only use 3 or 2 even. So yeah, just as an idea, that's sort of how you could use bolts in the CAD, but I don't think you really need it. In fact, it's almost more beneficial not to worry about that sort of stuff and to maybe catch things that you may miss if you were worrying about having bolts in your CAD otherwise. So let's go back to here, and you can see we've got our parts. We've got our parts, and these are the parts that we've been given to make this. And you can see we have our side rails here, which are 29 inches long. And we have our front and back rails are 29 inches long. Our side rails are 27. And then we have 4 T-gussets. And then we have our wheels, 2 traction, 1 with a sprocket, which goes in the back, and then 1 which just attaches to the gearbox shaft that comes out here, right? This goes around the gearbox shaft. And then you'll have your omnidirectional wheel, which will go right here. So yeah, first things first, we need to have a fixed component. So let's move one of these VersaFrame pieces into place. Right, we'll move it here. Move it here just so it's on the back, and we'll have this be the back framer. We'll fix this. We'll move both of these over just a little bit so they're out of the way. And we'll do it like that. All right, so now we'll add a gusset to our CAD here. We'll add a gusset. And we're going to go ahead and press M for mate. or you could just go up here and say fasten mate, right? Which, recapping that, it restricts all degrees of freedom between 2 points. And we can go ahead and click the bottom hole here, and we'll put it on one of the holes here. Now, which hole do we know which hole do we know to use? It's going to be the 4th hole. If we go ahead and look at this, we can see that there are 2 holes showing. I'll go back over to here just to show this. There are 2 holes showing, and then one is also used, and then one that's aligned with this piece here is the 1, 2, 3, 4th hole, the 4th hole. And then we're going to be using the 1st hole of this one. You can see that's the 1st hole it's showing. So if we go back to here, and if you look at the naming convention there, 4795-20-A-100, that's sort of our naming convention, 4795 being our team number, 20 being the year that it is, A being assembly, and 100 being an assembly number. So yeah. Go back and edit this mate, and we'll click the 4th hole here. And that's going to move this over. Now we do have a problem here, it's pointing the wrong way. So we can go ahead and use this reorient secondary axis button to flip it around twice, and there we go. If we wanted to reorient the primary axis, we could as well. But that would sort of just make it inside the other one, and we don't really want that. So right, we've got this here, and we'll go ahead and use our fasten mate again to mate this end hole here to this gusset here. And we can actually go through to the inside of this hole if we don't want to change our camera orientation to look around, and it'll have moved there when we look back. And now we're going to do another mate here. We'll go to this one right there, and we'll go to this hole here. No, is it this one? It's this one. This one there. And you can see it's upside down. We'll just do this, and we can flip it around that way. That way, like, you don't have to change your camera orientation. Really, I'm just trying to show you guys options. You do whatever works for you in your workflow. And now we'll go ahead and constrain this front rail here with our 4th hole over, as we remember. And we'll constrain it up here to this. We'll go ahead and drag this out of the way. We don't want this here. We'll go ahead and drag this right there. Right, and we'll make a check mark there. So now we've got these parts of our drive base here, or of our chassis rather. And so we'll go ahead and finish constraining that just real quickly, right? So we'll click this, click the 4th hole over here, click check there, we'll go through, we'll grab this one, this hole right here. Got to get in close sometimes, because it'll, get stuck on another one. Sometimes you just got to get in close and tell it what's up. And then we'll click this, and now our drive base is actually fully constrained, even though it only has 3 gussets, right? It's fully constrained even though it only has 3 gussets, and that's just because of the fact that it's CAD, and so these constraints are really all you'll need currently. But yeah, so you can see if we drag this, in real life it would sort of bend and flop, and we don't even have bolts through here, but yeah, in real life it would sort of move around. It won't here because it's fully constrained. So now we can go ahead and add the rest of our gussets to our CAD. Start with this final one. Actually, you know what? I'll just go ahead and pause the recording, and I'll show you guys it when it's done. All right, and there we go. Right, there we go. It's all constrained, and that was literally just, repeating what I had done before, just doing some busy work and getting those all mated together. All right, next thing, right, we've got this drive base. It's all constrained to this fixed member here. So it's all constrained here. Next thing we're going to want to do is add our bearing blocks. Now, I have something called a group on these, which is basically a way to just stick parts together. In real life, when you imported these, you would probably group them because this bearing block might actually import as an assembly, although it looks like it's just a bearing block here with a bearing and another bearing block and a bearing and then bolts holding them together. Right, there's threading here, and you tighten and loosen these bolts to get them to clamp down. And actually, the bearing blocks, what they're supposed to do is basically they allow you to slide your shaft, your wheel shaft, so that you can see you have a sprocket here, so that when you connected your chain here and here, right, you could loosen these a little bit and then slide this bearing block back, and then that would allow you to tension your chain. So if your chain's a little bit loose, loosen this, and then you use something called a cam tensioner, which would be put in this hole here, and that rotates and slides your bearing block back this way. And that allows you to keep your chains tight and tensioned, which is a really useful tool. So this drive base platform is called a West Coast drive because of these West Coast sliding bearing blocks. So now we'll go ahead and add our grouped bearing block on here. So in real life, right, you would have inserted these and then mated them all together in an assembly, right, after importing these from wherever you downloaded them, probably Vex or West Coast Products. And you would do the same sort of deal with the other ones. Right now, though, I have them grouped, right? Just for our purposes today. So we'll go ahead and make copies of this. However, so we're going to have to make copies of this, right? So we're going to select the whole thing using the highlights that we talked about last episode, right? Up and to the left selects everything, anything that's even partially contained, and then then to the right selects anything that's completely contained. So if like you did this, it would select that sprocket there. If you did this, here I'll try to give a good example there. If you did this, it wouldn't select anything, although sometimes it sort of freaks out and selects random stuff. But you see there, it wouldn't have selected anything, but here it will select all of those things that it's touching. So yeah, there's the distinction there. So now we'll go ahead and copy that we can actually just click copy 6 items, and then go ahead and paste that in. But now you can see when we move this one around, right, this is grouped together. If you go down here to our mate features section of the assembly, you can see that we have this group. When I select this, it's going to select, it's going to go ahead and show us the group. Actually, it won't show us the group, but it's going to show us the group that we've got here. If we go up to this one that we copied in, yeah. So bearing block assembly, right? It's going to show us that. So now if we go ahead and drag this though, oh, actually, I guess we copied the group. I guess it wound up copying the whole group. But if we go ahead and copy and paste this, copy and paste, right? If we pull this, oh, I guess this must be a recent Onshape update, because typically when you move something in a group like that, it will actually like the constraints won't be kept. Like if I go ahead and copy just these 3 items, and I control copy and control paste here, if you pull one, it'll just pull independently. I was expecting that to happen here, but apparently you can now copy and paste groups, which is Onshape updates itself quite frequently, but that's a really nice feature that wasn't present before. I wonder if you go ahead and copy this, if you'll be able to paste it in here. Or maybe if we click this and control copy, and then we paste it in this way. No, I don't believe so. So we'll just have to keep selecting these, and then copy this. You can also press Control C, and then do 3 more of these, right? We'll need 6 total. And that's all we'll need. And now we can go ahead and use our mates to mate them to these holes. And that's just going to be a fasten mate. But I was going to show you how to do a group. But groups are also not, super useful. I'll show you how to do one in a second. But yeah, we'll go ahead and do that. Mate that to there. And actually, we have that on the wrong side that we mated. So we'll just go ahead and flip that main axis there. And you can see it's actually rotated, which is weird. Let's go ahead and try that again. These are all sort of being a little bit funky right now. Yeah, so let's go ahead and mate this. Right, we'll mate this. We'll select the inside edge here, and we'll go ahead and mate this piece right here to this piece right here. And it is wanting to be on an angle for some reason. Oh, you know why it is? It's because we selected the bearing and not the bearing block itself. I'm sort of a dingus like that. But yeah, we'll go ahead and press M here, and we'll select our bearing block, right? This one here, that center point there. And we'll go ahead and mate it to this, right? And now it's going to be fastened, and it's going to fit because we set it up to fit previously. That was not on camera. So now I've got one. We'll go ahead and add the others by literally doing the same thing. So we'll go in, and actually let me show you how to make a group real quick. We'll go ahead and delete this group, right? So now that group constraint is going to be lifted, so we'll be able to just move this like we weren't able to before. So we'll press Control Z to undo that movement, and literally all you do for grouping something is just you highlight it, and you select group, and you can name your group. You can name it bearing block group or bearing block assembly or something like that. And then now when you go ahead and move it, it will move the whole thing, right? All the entities that you selected. So now that we have those grouped, if you press M here, you can go ahead and select this bearing block and then move back to here, and we'll put this one on here. Oh, I guess it didn't select the bearing block mate connector there. Sometimes you got to select it a few times just so it sort of gets the memo. It appears, yeah, okay, that one's legit. That one checks out. So we'll go ahead and reach through here and grab this one. That's another thing you can do. Well, I don't know why you wouldn't be able to do it, but sometimes it's not apparent to people. But it is an easy way to just sort of save some time. Is just reach through and grab the other side of something, especially if there's a hole. Right, we'll click that, and we'll do this one. And I'll just show you guys this side, and then I'll do the rest off camera real quick, because I'm not trying to take up your whole day here. All right, so we'll go ahead and we'll add the rest of these now. All right, now that we've done that, I think we should be able to move on to our wheels. Now let's go ahead and check our reference build to see what's going on with our wheels. All right, so we've got wheels in the back here, and then we've got our 2 wheels and our 2 gearboxes, like this. So we'll start with the gearboxes. We'll go ahead and mate them. We'll say that they're mated here to the bearing blocks, and that's literally just a bolt that goes into the bearing block, into the chassis actually here. See right here, it bolts in. So we'll go ahead and add those. Go ahead and add those in our assembly here. And if we go ahead and see, if we just copy one piece like this, it'll just paste that, or it'll just paste that in. We'll undo that. But if we want to copy the whole thing, the group should carry over. Right, the group constraint should carry over. Yeah. So now we've got 2 of these, right? And we'll just use our fasten mates to mate those to the corresponding drive base elements. And you can see there's a big hole here because the bearing is already in the bearing block. So go here, and you just made it right to this bearing right here. Actually, no, you made it here because the bearing goes in the hole a little bit. Oh, apparently it didn't get the mate connector on the gearbox there that first time. Sometimes you just have to click it twice. And there we go. Now it's mated just like that, and we'll go ahead and do the other one. Like this. Make sure we got that. And then we'll go ahead and click this one. And this is actually going to need to be turned around. So we'll go ahead and click this, and that'll turn it around for us. And we'll also reorient the secondary axis. That way it gets just the right side up there, right? And there we go. Right, we have a drive base with gearboxes and motors. And now I already have these grouped, right? So this is going to be a little bit more simple than it would be when you're actually making this, but honestly not that much more simple. Like in real life, you would just be getting these plates and then putting all these gears in, which is not that many gears. It's only 1, 2, 3, 4, 5, 6. Then you have shafts for each one of those, and then you have 2 motors and then 2 plates. It's really only like probably not more than I don't know, probably not more than like 20 parts. In total, which it doesn't take that long to assemble something like this in CAD. And then once you have it assembled in CAD, you can just copy that assembly over and use it like we did. Alternatively, you can just not have the gears in there, or just have this as a rough outline, or even just make a mock-up there if you're doing like a concept or something like that, and you just need to know like what size is the gearbox, what space does it take up in the drive base, rather than like what specific part is it, how do you assemble it. That like this sort of detailed CAD model would tell you. Sometimes you don't need that information, so you can just use like a basic blocky mock-up or sketch instead of the actual part. So now we'll go ahead and add our wheels, and these wheels we'll have to go ahead and copy as well. So we'll copy those, and we'll paste them in right here. And I believe that they should retain their group characteristics. Okay, they have not, and that's good. That's probably just because we pasted all 3 of them at once, right? We didn't just paste a group. So we'll go ahead and group these independently. Grab the wrong thing there, or not the wrong thing, just the wrong group of things. We'll group these things independently. It shouldn't take too long. All right, and now this should be no problem at all, right? These should move around without falling apart. All right, cool. Now we'll go ahead and rotate these each 180 degrees. Right? So you'll just click on them, you'll highlight them, and you can transform them and move them around if you go ahead and do that. So we'll do that. 180. That's 810. That would not be the same as 180, I think. Yeah. I'm fairly certain. There. And then this one will also rotate 180 degrees. And you can choose however many degrees you want to rotate it by if you so desire. And then you can also choose different ways to transform it like that. All right, now we have our 6 wheels, and we'll go ahead and add them to our CAD, right? So first things first, we got to start our revolute mate, right? This is going to be different than our fasten mates. And we're just going to go down here, and we'll click this little thing here, and we'll go in, and we'll go ahead and select this bearing, right? That's what it's going to be connected to. And it'll just go ahead and revolute to that. And you can see that this shaft color will line up perfectly on the outside of this bearing because we already set that up in CAD. But if you were doing this, with the real assembly that you're starting from scratch, you would have that hex shaft with the right length just to poke out just enough from this bearing block that you can add this shaft color, which a shaft color basically just like, see it like you've got a little screw going in here, and this whole thing squeezes on this so that the hex shaft, this is a hex shaft, see it's hexagonal, so that when you put it in a hexagonal shaped hole, it can't move respective to the hole at all. So when you put this hex collar on it, right, when you put this shaft collar, it does not allow it to travel at all in this direction because it's sort of sandwiched around this. So because you don't want your wheels falling off, obviously, for obvious reasons actually. So we'll go ahead and put that one on our other side as well, in the same way. All right, and that should add that, and that's pretty nice. Now we've got our traction wheels, and we'll do the end traction wheels first. Do these end traction wheels first, because this is going to be largely the same. And right in a legit assembly, or when in a from scratch assembly, you would add this sprocket as well, which is nothing complicated. It's just mating it to this shaft or to the end of this shaft color here, and this is a spacer, I believe. So you go ahead and go here, and you click this, and it should be good to go. And then we'll do another one, right? We'll do the other side like so. And there we go, right? We have a four-wheel drive now. So let's go ahead and add the wheels that are that are being powered and that are powering the whole operation there. All right, so we're going to go ahead and add the spacer side of the wheel to the gearbox, right? So that's going to be here, and that's going to be quite simply just putting it there, right? It's not super complex, and there we have it, right? There is our wheel assembly there. And we'll do this last one, just like that. And now our drive base is pretty much complete. We'll have one last step before we at least conclude the assembly portion of this video. We'll go down here, right, and we'll add this, and that's just going to make that. It's possible that we actually didn't group this one. I'm not sure how that happened, but that may have been an oversight there. Or maybe that wasn't included in the group. That's also a possibility. We'll go back to up to our Revolute here, and we'll select this spacer here. And we'll go over, and we'll go ahead and mate it to this. And there we go. We have our completed CAD. Now all of these wheels will rotate, right, without falling apart. They will rotate. And yeah, everything is constrained together, right? None of this stuff is going to move. None of this stuff is going to go anywhere because it's all connected to this fixed component in some way or another. It's actually this one that's the fixed component because this is the back. But yeah, so, all right, now what we're going to do, right? Because if we look at this reference assembly, and this is how it would be in real life as well, when you spin one wheel, the other ones spin as well. So how can we get that to happen? Well, again, we're going to be using something we talked about in the last video, which is a relation. This time we're going to be using a gear relation, which is basically a mate between mates. So we'll go to our revolutes here, and we'll just do one side for now, just to keep it short. So let's go to our revolutes, and we have 6 of them, right? Got this 1, 2, yeah, so let's do this side closest to us, the right side. So we'll pick Revolute 2 here, right? That's this one showing up here. And we'll also pick Revolute 6 we'll pick, right? So we'll connect these two together, and we'll with a relation ratio of 1. Now if we spin one, the other one will spin. But they're spinning in opposite directions, so we'll have to go to this gear mate and reverse the direction. Sometimes you have to do that. You can never really tell which direction they'll spin in. So now they're spinning in the same direction. That's pretty cool. And now we'll go ahead and make another gear relation between these two. That's going to be Revolute 6 and Revolute 4. And we may have to reverse the direction again. I'm not sure if we will actually because of the same part effectively. Yeah, we will have to reverse the direction again. All right, and now if we go ahead and click this this Revolute mate right here and say animate, and we change these values just to make it faster and to make it go for longer, Then we can go ahead and press play, and this thing should spin, and the others will spin as well with it. So yeah, that's our CAD assembly. Again, if you were making this from scratch, you would be downloading all these parts and editing them, and these assemblies would not already be in the assembled configuration, or these sub-assemblies rather would not already be in their assembled configuration. But this video was just to showcase like how simple making these types of assemblies for robotics is, right? It's just mating things together, putting, pegs in holes and sticking everything together, right? It's not that complex. If we wanted to go ahead and make an exploded view of this, if we go ahead and look at our drawing here, right, that we made, and we won't get into, actually, you know what? Screw it. Let's get into making a drawing today. We've got a little bit of time. But yeah, so we've got this drawing here, right? And you can see that it's a drawing of an exploded view, and for now we'll just do a drawing of the regular isometric. But you can see here, if we go to this drawing here, and we go to an exploded view, and we go to add an exploded view, it'll allow us to edit it. And we did this a little bit in the previous video, where you can literally just drag stuff around. It ignores the mates that are there, and just lets you drag stuff around. And if you click more stuff, it'll move it in the same manner. Right, and then we can also, we'll go ahead and remove that explosion there. Remove that. No, we don't want to add that to it. Man, I'm really goofing up here, man. But yeah, so now we've got that, and then we can also go ahead and move these up. And we won't do the whole thing, right? But making an exploded view like the one shown on the paper there, or on the document, on the drawing, is literally just, clicking on things and dragging them to the place you want them to be shown. You don't really need super big dimensional accuracy for an exploded view, just because it's literally just an assembly reference, right? So we'll just have this, and this will be called small explode video demo. We'll call it that, just for now. And we'll say done, right? We're not editing it anymore. And if we go ahead and click that, it'll show us it, right? So that's a basic exploded view, and now we'll go ahead and right-click this and say create drawing of this assembly, right? And we'll go to our custom template here and just say do not include everything. This is just going to give us a blank sheet of paper. All right, blank sheet of paper. And now we'll go ahead and open up this drawing, and it's going to prompt us to open up to insert a view of our assembly. So what you would do here is you'd go isometric, which basically just means from the corner, and you'd do explode position as demo, as video demo, and then you can change the scale to something like 1/10. Or actually 1/6 might be applicable. That's going to be pretty big, but I think we might want that. Yeah, that's pretty good. All right, cool. All right, now we've got this video demo as a reference in our explosion there. And if we wanted to go ahead and change our explode position, we could. If we want to go ahead and insert another view, it's going to take a second to load here. If we want to go ahead and insert another view, right, I can click insert view here, and we can maybe add a view from the isometric perspective, but no explosion, and in a smaller scale, and this can be used as a reference for manufacturing, right? So they can have a completed reference. So this will be down here. Maybe we'll do like a bigger scale than 1/20th. Maybe we'll do 1/16th, right? Like that. And we'll put it there. So now what we'll be able to do, right, is right click on this if we want to, and say show shaded view, right? And now it's going to show in the shaded configuration that we can see in the document, right? You'll be able to see this shaded view right here. And this one automatically will show in sort of a more wireframe view with visible edges shown. And you can also right click here and say like, I don't know, you could say show hidden edges. Let's see where we can say that. Show hidden lines. And that's going to give us a little bit more like things going on underneath, right? We'll be able to see all of our hidden lines. So some areas will just look really dark, but we can zoom in and check those out if we want to. And then if we want to, we can right click on this or double click on it to edit the little window up here. And then we'll be able to change our explode position. So now we'll be able to see our hidden edges. And if we go ahead and zoom in on that, it's going to really get mad at me for doing this because it's a lot of complicated geometry that it now has to show. But it's going to get pretty mad at me for doing this. but if we want to go ahead and zoom in on that, we can, just like we have. All right, yeah, so that pretty much concludes our final guided assembly video, right? And basically what we learned today, right, was that, right, CAD is not that complex, especially a lot of the things that we're doing with CAD is just making pretty simple designs. And the reason they're simple is because we have to be able to build them, right? That's the reason they're simple, because we can't really build complex things, which is useful for a designer because it makes the translation from your design, which can have simple assemblies in it and still be pretty, smart, a pretty effective design, right? But you still have a pretty simple design, but you can, translate it from your head onto the CAD very easily if it's simple, if you're working to your strength manufacturing-wise. So CAD, right, again, like I've said many times before, CAD's not where you do your design. Usually I do my designs in my head first, right? Like I'll think of them in the shower or something, and then I'll do a 2D sketch on graph paper with a pen. Like one of my creature comforts in life is graph paper. I guess that tells you all you need to know about me, but I really like it. I think it's pretty cool. But yeah, usually I'll do a 2D sketch on graph paper, and then, after that, after I sort of, flesh out what I have to design, then I'll do it in CAD, right? So your workflow looks like the first thing you're going to do, of course, and this is something that, you've seen if you take any PLTW classes or any sort of engineering classes, they'll say, like the engineering design process, first step, like identify the problem. Next step, brainstorm solutions. And that's actually true. Like the first thing you're going to do is identify the problem. That's the key thing to do in task-based design is identify the task. The next thing you're going to do is think of some concepts, right? So what, general things, like without getting into specifics, could fulfill this task, could complete this task. And then you're going to get into researching these things that have been done before. Like what are ways that people have already completed this task? Because, you don't want to reinvent the wheel. Like, building off of other people's designs, that's where the best designs come from because they've already been fleshed out twice or maybe even more times. And there are many ways to do the right thing or to do something that works well, but oftentimes some things will work better than others. So yeah, like learning CAD and learning design are different, right? CAD is a tool, and it's just a part that's later in the process. So after you've made these design decisions, right? You've come up with concepts, and you've come up with like 2 or 3 concepts that you think could maybe work well. Then you want to make paper sketches of those, and then pick between those 2 or 3 concepts to get one that you're sort of happy with. You can take those concepts into CAD if you're really having a hard time deciding, and that's what most professionals do. But like for our purposes, it's fine to just go ahead and draw out our concepts on CAD, and then once we have that, right, we can make our design decision as to like should it be tall or small, or should it be heavy or light, or should it be made of this material or this material, right? Those are going to be the big types of decisions that you're going to be making in that paper drawing phase. And then you're going to draw out a little bit more of a fleshed out sketch, right? So this is sort of a sketch of what your CAD is going to look like. And that's sort of where you start to catch some of the smaller details. And then after you do that, then you can move on to CAD. So if the design is fleshed out before you get into CAD, if it's well fleshed out to begin with, your CAD is going to go really quick. It's going to go like that, like lightning. And that's just because, you're not doing any design work using CAD. You already have the design, made, right? And it doesn't take as long to draw it out on graph paper. And then CAD, you can translate that pretty well. And then you can start to see some of the more, detailed things. Like you'll hone in. You start very broad with your designing, and then you slowly get narrower and narrower in focus until you're just, catching like hardware issues in CAD. And that's how the process is supposed to work. And if you do that, right, after you've made the CAD, then you go through the process of showing other people your design and having them review it, and then also reviewing it yourself with like hopefully a neutral perspective. And then you can iterate that, and then you can build prototypes, just to test feasibility, and then also to test different things about it. We won't get too much into that design process today, but yeah, just have a general idea that CAD is not where your design happens. It's just a tool and a part of the process, but it is a really important tool to know how to use when you're designing in this process. But yeah, right, as always, practice makes perfect. Right, so these things are not that complex. Maybe try, coming up with a task and then going ahead and making an assembly that could complete that task. Even if that task is just to have like, a joint, like we talked about last lesson, right? That right angle joint. Maybe that task is just to hold two things together. And that task, that design would be like, some gussets with some bolts through them in order to hold everything together, right? That could be your task. It could be as simple as that. Or maybe the task is more complicated, like, I don't know, intaking a ball, or like using some sort of game piece, or being a drive base, right? Driving around. That's another task. The thing that we just did would fulfill that task of driving around, and I know that would fulfill that task of driving around because we used it in the 2020 season and it worked quite well. It's a pretty fleshed out, pretty simple design. Um, but yeah, so this is going to be our final guided CAD work, right? We sort of have all the basics of CAD. I've at least told you all the basics of CAD. You probably don't, know all of them yet, just because, or you're probably not, super practiced in CAD. This is really all the information you'll need to do well in CAD. The rest comes with time. So I think I've given you all the information I can without, being giving an overload. And even then, if I said more stuff, again, that's just going to be spending time. And spending time is what we're going to need to do to learn this stuff so that you can be more proficient at designing or at using CAD to enact your designs. But yeah, next phase of the curriculum is going to be like we already talked about, context-based design, right? Like what contexts are, or like what what things are already in existence for robotics, like what parts and assemblies we have, and the general workflow and the general design philosophy of robotics, but also just of practical design in general. And then we went into CAD basics, starting out pretty abstract, pretty unrelated to robotics, and then moving into, some other stuff, like using common off-the-shelf parts in our designs, in our CAD designs, and then using, some more complex assemblies. And next, right, we've completed all that. That's really all you need. Next, what we're going to be doing is using that and doing a project, right? That's what we're going to be doing. We're going to be doing 3 projects actually, and they'll sort of ramp up in how much I'll babysit you as we do them. But yeah, we're going to be doing 3 projects, and those projects are going to be designed to sort of help you bridge the gap between designing and CAD, and then get comfortable with that. And that way, when we get to the build season, and we'll actually do some CAD before the build season just to sort of iterate the robot a little bit. But that way, when we get to the build season, you guys will be ready to go. But yeah, as always, if you have any questions, please let me know. I would love to answer them, and I will, answer them as best as I can. So yeah, thank you so much for watching, and I will see you all next time.